Jai Hind Vande Mataram. So welcome back to part 2 of the projectile motion. We will be starting with the time of flight equation. So if you haven't watched the part 1 of my video, please do that to get the better understanding of the topic. So now in deriving the time of flight equation, I would like to say that at time is equal to 0, the ball was here. And let's say at time is equal to small t, the ball is at maximum height above the ground. So ground meaning the positive x-axis. So I would like to make a point that from time is equal to 0 to time is equal to t, whatever time this projectile is taking to reach from time is equal to 0, that means from the bottom of the ground to the top, the same amount of time will be taken by the ball from t is equal to t to again reach back at this particular final location. So I just want to say that from here to here, suppose the time taken is 2 seconds. Then from here to here back, again the time will be 2 seconds. So the time taken from here to here and from here to here are the same. So what we are going to do is we are just going to find out the time from here, the initial position, time is equal to 0, to the maximum height, time is equal to t. And if I get this time and if I double it up, I will get the time of the entire motion, and that itself is known as time of flight. It's like aeroplane starting from here. You may consider this as a small aeroplane starting from here, and it reaches its destination, say somewhere over here. So that is the total time of the flight. That means I'm going to find out the time from here till the top point, and I'm going to double it up. So what is most important for us is that at the maximum height, the velocity vector v is exactly parallel to the x-axis, which means the y component of velocity is going to be 0. Alright, so I'm going to use this part. So we do know that v is equal to u plus at, and if I write this equation for y-axis, uy plus ay times t. As mentioned in the previous video, that ay is minus of g because it is the vector along negative y direction. This time t is what we are interested in finding. This is the final position of the ball. This is final position, and this is the initial position. And you know that the initial velocity is u, and this angle of projection is theta. So uy is u sine theta. This is, sorry, ux. This is u cos theta. I should better rub it off. This is the x component, so that is ux, and that one is the y component. So this is ux, that is equal to u cos theta, and uy is the initial component's velocity along y-axis. So that is uy, that is equal to u sine theta. So here I am going to substitute u sine theta plus, and then vy is 0 because the final position's y component is 0. So from here I am going to get the equation is t is equal to u sine theta upon g. So that means time of flight, capital T, is the total time of the journey, that is twice of the t, that is equal to 2u sine theta upon g. So this is the time of flight equation. Right, now what we are going to do is we are going to find out the equation of trajectory. So that means we need to prove that this entire path is parabolic, right? And the y against x graph is parabola in nature. So the entire path is not a straight line. Like I should say that for straight line, the graph of y versus x is this, and y is equal to mx plus c. So here this is y and here this is x. So we need to prove mathematically that this is not a straight line graph of y and x, correct? What is y and what is x? I'll discuss. So first of all, we do know that s is equal to ut plus half at square. And if I write this equation in terms of y, then y is equal to uyt plus half minus g e square. And then x is equal to uxt plus half ax t square. So we do know that ax is 0, so this is going to get cancelled. So x is equal to ux is u cos theta, because we do know that this is initial velocity u, this is theta, so this is ux, that is equal to u cos theta times t. Correct. So this value of t I am going to say as x upon u cos theta. And this value of t I am going to substitute in this equation. Now let me tell you what is y and x. So suppose if I say, let me rub this part, that initial position of the ball, where it is, the initial position of the ball is here, time is equal to 0. And let me call this as the final position at time is equal to t. You may take ball anywhere where you like. This is at time is equal to 0, initial position. So initial position and final position, I'm going to join this with the help of a straight line, arrow towards the final position. This is my displacement vector s, which is mentioned over here. And the component of this along x-axis is x, and the component of this along y-axis is y. So this is y, right? And this angle is theta. So that is x and y which I'm going to talk. So now y is equal to uy, that is u sine theta, times t, this is the value that I'm going to substitute, x upon u cos theta, then minus half g, and instead of t I'm going to use x square upon u square cos square theta, which means y is equal to u getting cancelled, sine upon cos is tan theta, times x minus half g upon u square cos square theta times x square. If I want to call this as a and the coefficient of x square as b, then y is equal to ax minus bx square. This is definitely not an equation of straight line. Correct. This is an equation of parabola. Right? Simply remember, on one side you have y, on another side you have x. Then any one of y and x has power 1 and the other has highest power of 2. That means it's an equation of parabola. So this is definitely not an equation of straight line. So the body is performing parabolic motion. Let's go to the maximum height part. So at time is equal to 0, the ball was here. At time is equal to say t, the ball reached its maximum height. So I'm going to now use equation v square minus u square is equal to 2as, and I'm going to apply it to the y-axis because I do know that the shadow of the ball would be moving along positive y-axis if we place a tube light like this. So this is the light. So the shadow will be reaching over here. This is the shadow at maximum height, right? And this is the shadow of the ball itself at time is equal to 0. So I'm going to simply apply the y-axis formula over here. So vy square minus uy square is equal to 2ay, that is minus g times y, correct? And we do know that at the final location vy is 0 because here at this particular location over here at maximum height, velocity is purely parallel to the x-axis. So y component of velocity is 0. So simply this term is 0 minus uy's initial component, initial velocity is y component. So that is uy, that is u sine theta. We already know that u sine theta whole square is equal to minus 2gy, and this 2 and 2 getting, sorry, minus minus getting cancelled. So y, that is the equation of height, and that is equal to u square sine square theta upon 2g. So this is the equation of the height. And if you want maximum height, I should say y max, or I must say h max, that should be equal to u square upon 2g, because sine square theta can also be written as sine theta the whole square, and maximum value of sine theta is 1. So if you want to make h is equal to u square sine square theta upon 2g to be maximum, you cannot change u, you cannot change g. So to make h maximum, you have to take maximum value of sine square theta, which is 1. Sine theta's maximum value is 1 and its square is again 1. So that's why I should say H max is equal to U square upon G. And that is only possible if theta is equal to 90 degree, because sine 90 is 1. So you need to throw the ball up like this, vertically upwards, to get the maximum height. Okay. Let's find the horizontal range. Now this is the easiest part, because at time is equal to 0, the ball was here. Now I'm going to place the tube light up, which is going to throw the light downwards. Now when this ball reaches over here, its shadow is here, and when the ball reaches over here, its shadow is here, and the distance traveled by the shadow of the ball in x-axis is known as range. So now I'm going to use the equation, this s is equal to ut plus half at square along x-axis, because range can be found with the help of x-axis, and you will understand it why. X is equal to, because I'm applying it in x-axis, uxt plus half ax is 0 t square, so this is gone. Now x, I'm going to call this as range, that is equal to ux, that is initial velocities, x component, so that is u cos theta, times, if I substitute time of flight, that means I'm going to take the time for the entire journey. So that means range is equal to u cos theta times, why the time of flight? Listen to me once again. See, if the ball is here at location number 1 here, correct? Then this is the displacement, then this is the value of x, correct? Now if I change the location of the ball, suppose here, this was the ball's position at time is equal to 0, and now if I take location number 2 as the location of the ball, this is the displacement vector and its x component, this is the range. So if I want to find out maximum range, this should be the initial position of the ball and this should be the final position of the ball, correct? Which means the x component would be simply equal to the entire time times the x component of the velocity, correct? And time of flight we just now found, let's see that, 2u sine theta upon g. So here 2u sine theta times g, so this is equal to 2u square sine theta cos theta upon g, which is equal to u square. Now 2 sine theta cos theta is sine 2 theta by g. Please remember this identity if you are new to grade 11. So 2 sine theta cos theta is equal to sine of 2 theta. You might want to check this identity with the help of an easy example. See, if I say sine 90, that means 2 theta is equal to 90 degree. That means here 2 sine theta is only 45. Again cos of 45, and you check, this is 2, 1 by root 2, again 1 by root 2, and that is equal to 1, which is the right hand side sine 90 as 1, because root 2 is 2 getting cancelled. Now I just want to make a point that if you want the range to be the maximum, what should be the value of theta? Again, if I want to say that for the range to be maximum, what should be maximum? We should have maximum value of theta, I mean sine theta. So you cannot change u, you cannot change g. So sine 2 theta has to be maximum. Sine 2 theta has to be 1. That means sine 2 theta has to be 1. That means 2 theta has to be sine inverse 1, that is 90 degree, which means theta should be 45 degree. So if you throw any projectile at an angle of 45 degree, the range will be maximum compared to the other angles, right? And if you want to find out maximum range is simply u square upon g, because sine 2 theta is 1. So I hope these equations were helpful. Please post your doubts if you have any. Thank you very much for watching the video.